Hi friends, welcome in the lecture of class 8 mathematics CBSE board lecture number 5 chapter 1 rational numbers, and in this lecture we are going to study about integers, definition of integer, properties of integers and laws of integers. Before start this class, I would like to request you, please subscribe my channel, like it, share it and press the bell icon so you will get all the notifications of upcoming videos. And from class 6 to class 10th mathematics subjects videos are uploaded, and if you want to search them, so you can search by with my name Mahesh Volande and your class. Suppose you are in 8th class, then you have to search Mahesh Volande class 8th. You will get all the videos of class 8th. And if you want to search particular chapter, so you can search Mahesh Volande. Suppose you want to search integers or rational numbers, so you may search Mahesh Volande rational numbers. So you will get particular chapters videos. So let us start. What are integers? Integers are the combination of all natural numbers, negative natural numbers and zero. Or we can say that all whole numbers and negative of whole numbers. Zero is neither negative neither positive. Positive numbers are right to the zero and negative integers are left to the zero. Symbol of integers is capital I or capital Z. Both symbols are used to represent integers, capital I or Z. Next point is properties of zeros. First property is there. Zero is neither positive nor negative. Just we have explained there. Zero have no sign. It is not positive, it is not negative. But we may consider it as positive as well as negative. Whenever there is a sign of negative in front of zero, whenever there is a zero, in front of zero we can place plus or minus. We can place plus also or we can place minus also. Now next property is that there is no smallest and greatest integer, because if we want to find smallest integer, -1, -2, -3, so for every smallest integer there exists smallest smaller than that number. So we cannot find smallest integer and we cannot find greatest integer. Negative integers are smaller than positive integers. Negative integers are always smaller than positive integers. There are infinite or uncountable integers. Integers we cannot count in both the sides. In positive sides we cannot count integers, and negative side also we cannot count the integers. So there are infinite number of integers. We cannot count them, so they are uncountable. All natural numbers are integers, but all natural numbers are integers, and also all whole numbers are integers. But the converses are not true. All whole numbers are natural numbers, all integers are not natural numbers, and all integers are not whole numbers, because natural number starts from 1 to infinity. Whole number starts from 0 to infinity. So natural number is the smallest set. After that there is a whole number set, and that includes integers. So whole numbers are from 0 to infinity, 0, 1 to up to infinity. But integer contains negative of natural numbers, and negative of natural numbers does not belongs to whole numbers, and negative of natural numbers are not natural numbers. So integer is the largest set among these three sets. So all natural numbers are integers, all whole numbers are integers, but all integers are not whole numbers, all integers are not natural numbers. Now if we take two integers, first is positive and second is negative, and if we multiply them, we will get negative integer as a result. If we multiply negative integer with negative, we are getting positive integer. Next property is there, if negative integers are taken odd number of times and multiply them, we will get the result as a negative integer. If we take three negative integers and if we multiply them, we will get the negative result. Minus into minus plus, plus into minus again negative. So there are three numbers. 3 is odd number. So there are three integers which are negative. If we take, in fact, we take 5 odd numbers. 5 is odd number. If we take negative number 5 times and multiply them, we will get the result negative. Whatever be the multiplication of the integers, of the numbers, but the sign of that integer will be negative. If we take odd number of times negative integer and multiply them, if we take even number of negative integers, then we will get the result positive. One example is there, if we take negative integer 2 times and if we multiply them, we will get positive number. And if we take negative integers 4 times, their multiplication will be positive. If we take negative integers 6 times, their multiplication will be positive. Next point is the laws of integers. As we explained before, first law is closure law. Now, closure means what? Closed. If we take two integers and we perform any of these operations, the result should be also integer. Then we can say that the operation is closed for the integers. Now, if we take any two integers and add them, so always we are getting an integer. So we can say that addition of integers is closed, and it is written as a plus b belongs to capital I, or a plus b is always an integer. If we subtract two integers, subtraction of any two integers, we are getting integers. Subtraction of any two integers, always we get negative integer. You may take any example, or you may take any two integers and subtract them. Suppose there is one example, 5 minus 7. 5 is integer and 7 is integer. If we subtract 7 from 5, we are getting negative minus 2. But minus 2 is also an integer. Here negative of natural numbers are also integers. So minus 2 is also integer. So a minus b is always an integer if a and b are integers. Those numbers which are not integers are decimal numbers. Now here a is not decimal number, b is not decimal number. So their subtraction or addition will not be a decimal number. So in both these operations we are getting integer as a result. Next operation is their multiplication. If we take any two integers and multiply them, we are getting the result integer itself, whether it may be a positive or negative. If a and b both are negative, then their multiplication is positive. And if a and b are integers, then their multiplication will be also positive or also an integer. For division, if a and b are integers, A divided by B need not be integer. Here we have used word need not be because sometimes division of integers is integer, but sometimes division of integers is not integer. One example of each we have taken here. If 10 divided by 5 is there, so the result is 2. 10 and 5 integers, their division is also integer 2. 3 and 2 are integers, their division is not integer 1.5. Sometimes we are getting integer, sometimes division we are not getting an integer. So we can say that need not be integer. Need not be means sometimes we will get integer, sometimes it will not an integer. Next law is their commutative law. In commutative law, we are performing 4 operations: addition, subtraction, multiplication and division. So if we add the two integers by exchanging their positions, both the times we are getting same result. Let us take one example. -2 and -3 are the integers. If we add like -2 plus -3 or -3 plus -2, in both the cases we are getting -5 as the result. Plus into minus will be there. -2 -3 will be -5. Same sign is there, so we have to add them and put the sign of greater number -5. Here also -3 plus into minus, same sign is there, so we have to add them. 3 plus 2 5, greater number sign -5 will be the result. So in both the cases we are getting same result. So addition of integers is commutative. We can say that addition of integers is commutative. While subtraction, a minus b and b minus a. Here there is one example, 3 minus 5 and 5 minus 3. 3 minus 5 is -2 and 5 minus 3 is +2. In both the cases the result is different. So -2 is not equal to +2. Hence we can say that subtraction of integers is not commutative. So a minus b is not equal to b minus a. Now for multiplication, take any two numbers or any two integers, multiply them by exchanging their positions a into b and b into a. Both the times we are getting same result. One example is there. Suppose -2 and 3 are the numbers. If we multiply -2 into 3 and 3 into -2, minus into plus minus, 3 into 2 6, plus into minus 3 into 2 6. In both the cases the result is same, -6. Hence we can say that multiplication of integers is commutative, and we can return it as a into b is equal to b into a. For division we already explained in previous videos. If you want to search previous videos, you may search Mahesh Orande, class 8 CBSE, lecture 1, 2, 3 or 4. You will get all the videos in which we have explained the commutative property for all these operations in detail. Now here we can say that division of integers is not commutative. Let us take one example. 10 divided by 2, 5, and 2 divided by 10, 0.2. In both the cases the result is not same. Hence we can say that division of integers is not commutative. Next law is their associative. For associative, we should take 3 integers. Suppose a, b, c are the integers, and there are 4 operations: addition, subtraction, multiplication and division. If we have to add these 3 numbers, a plus b plus c, like this, so by changing the place of bracket, we have to perform the addition. First, put a bracket for B and C, and second, put the bracket for A and B, and simplify each of the expressions. In both the cases, you are getting same result. So addition of integers is also associative. These all operations, when we take the natural number, set of natural number, these all operations behave same like integers operations on natural numbers and operations on integers. In both the cases, all these results are same. Hence, addition of integers is associative, subtraction of integers is not associative, multiplication of integers is associative, and division of integers is not associative. You may take the numbers and you may check the results. If we take A into B first and then multiply with C, and if we multiply B and C first and then multiply with A, in both the cases we are getting the same result, and for division we are not getting the same result. Hence, division of integers is not associative. Next lies their distributive law. There are two distributive laws. One is their distributive law of multiplication over addition and distributive law of multiplication over subtraction, where if there is multiplication over addition, in bracket there is addition and there is a subtraction. So we have to multiply the bracket with A into or with A. We have to multiply B with A as well as C with A. And here also we have to multiply B with A as well as C with A. So the result is A into in bracket B plus C is equal to A into B plus A into C. And here A into B minus A into C. If we exchange the places of these two numbers, A and this bracket, if we put bracket first, B plus C, and multiply the bracket with A, then also we have to multiply with A to both these two terms, B into A first, then plus C into A. If there is a sign of negative in bracket, then also we have to multiply with A to B and C, B into A minus C into A. Next lies their additive identity. Identity element means which gives the identity to any number, and additive identity means we have to perform operation of addition. Now, which is the number when we add with any number gives the same result, like that number or the number itself. So 0 is an identity element, because if we add 0 to any element, we will get that element itself. So 0 is additive identity. Next lies the additive inverse. While taking inverse, the result should be identity element. Now additive inverse, we should get the result additive identity. Which are the two numbers for those we are getting 0 as a result of their addition? So there are two numbers, A and minus A. If we add A and minus A, we will get 0 as a result. So both A and B are the inverses of each other. Means A is the additive inverse of minus A and minus A is the additive inverse of plus A. Because A and minus A, if we add them, we will get the result 0. Now multiplicative identity. We know better that 1 is a multiplicative identity, because if we multiply by multiply any number by 1, we are getting the number itself. So 1 keeps the identity of A same, or after multiplying with 1 to any number remains the identity of that number unchanged. So 1 is the multiplicative identity. Identity is the number for particular operation. After performing this operation with that identity element, it will give the identity of the other number. So it will not change the other number. So resultant is the same as that number. So in this way we have finished today's class. So we will see you in next class. Thank you so much.